Okay, so we're going to get started today with your exercise 211, and it's kind of a natural progression where we started with rectilinear objects, we moved into doing the cushions, and now we're going to start manipulating larger surfaces. Over the next, I'd say, 3 or 4 exercises, we're going to spend a lot of time with some topography, and I think it's a good undulating surface to practice with, and it's obviously going to be at a large scale, but it's also something that you're going to end up having to do rather frequently, or at least work with rather frequently. Here, when you're doing your studio projects, whether you're in 121 or you're in 220 or 221, virtually all the sites that they give you are always flat, or close enough to being flat not to worry about it. I promise you, when you move on to Berkeley or Cal Poly, the first thing that's going to change is you will never have a flat site again. It's always going to be a hill. And so you have to learn how to deal with hills. And I've asked past students who've gone on to Berkeley, I always ask, what helped and what didn't help as they're going forward. And one of the things that they talk a lot about helping is this whole idea of topography, manipulating it. How do you build a physical model from the topography? So the next 3 or 4 days of class where we go through all of these things end up being important later on. If you can master this and be very comfortable with this skill, I promise it will help you a great deal going forward. So today's our first day of dealing with topography. What we're doing today is we're bringing some topography that we get from SketchUp into Rhino, and then we're manipulating that surface and transforming that surface and making it a better surface to work with. We're using we're using SketchUp as our source of the topographic data. In practice, you would be given some kind of a site survey from the licensed surveyor or whoever was doing the property boundaries and that sort of thing, in which case you'd be importing that exact site information into your site. In our case, we don't really have exact site information, so we're using kind of generic information. The stuff that's available in Google is not perfect, but it's also reasonable. It's okay. And so we're going to use that as a starting place for us, and certainly it'll give us some idea. As much as SketchUp is not my favorite application in the world, this is a good use of SketchUp. I should also point out that if you try to do this at home and you have the free version of SketchUp, the non-pro version, in 2018, I think it's in the 2018 version, it might be in the 2017 version, they stripped the ability to do this out of the non-pro version. So we have the pro versions on the computers here. It's not a problem. You can do it. But if you have the free version at home or on your laptop, these options won't be there. So it's important for you to know. I went ahead and I opened SketchUp. I'm assuming at this point all of you are capable of opening SketchUp. So I'm gonna make that assumption that you can do it. I went ahead and I opened it. And first thing I'm going to do is delete the little person, because we really don't need him or her in there clouding things up. And I'm going to try to do as little as possible in SketchUp, but I am going to go get that topographic data. So the first thing that I'll do is I'll go up to the File menu, and you'll see a sub-menu called Geolocation. And under Geolocation, I'm going to click on Add Location. And when I do that, I will get a nice map that I can choose to pick a piece of topographic data. I could, for example, pick Mount Diablo. If I zoom in here on Mount Diablo, there's probably Mount Diablo somewhere. Why am I not seeing it? There it is, Mount Diablo. So as you start to zoom in, you will see a white square appear. When that white square appears, that represents the maximum amount of topographic data that SketchUp will let you pull out. So you want to make sure that you're zoomed in far enough to see that white square appear. And then it's a matter of actually kind of sorting out what piece of topographic data you want to pull. It's entirely possible that you'll pull some topographic data and then decide afterward that you don't like it, in which case you can do this process over and pick a different piece of terrain. We will be working with terrain over the next 4 or 5 classes. So if you pick a piece of terrain today and you hate it, you can pick a new one next class. It's okay. Furthermore, I will be repeating myself several times over the course of the next several exercises. You will find that the stuff that I've already talked about, I'll go through faster, but I will still repeat the process. So now that I have this particular piece of Mount Diablo picked, I've picked a bunch of places. I picked in Hawaii before. You can pick anywhere that you want. Some areas have better, denser geographic data than others, and you'll discover which places have more geographic data than others. Anyway, once I've gotten to that point, I'm going to click the Select Region button. And you'll see that in my case, the maximum size that I'm allowed to select is that white rectangle. So I can't pick anything larger than that white rectangle. It's capping me there. And I'll go ahead and click on the Grab button. SketchUp will bring in that terrain data. It looks flat right now. So if I'm looking at it, it just looks flat. However, I can go to the File menu, go to Geolocation, and choose Show Terrain, in which case I should see the 3D version of that terrain. So it's under File, Geolocation, Show Terrain, after you've already gotten the terrain. And this gives you a sense of, do I like it? Is it working for me? Do I like this particular piece of terrain? So in this context, it's reasonable. This isn't my best, most favorite piece of terrain in the world, but it's going to work for what our purposes are today. And again, you can pick whatever one that you want to bring in. When I'm done here, I need to save this SketchUp file. I'm going to go to File, and then I'm going to choose Save As, not Save, because I need to go back a few versions in SketchUp. So I say on the sheet to save it as a SketchUp version 7. Rhino's updated quite a bit since I originally wrote the sheet. My guess is that somewhere in the 2014, 2015 would work just fine. I'll try 2014 and see. I just want to go back a couple versions. And I'm going to save that on my flash drive into today's folder. So let me go back here. And this is spring of 2018. Oops. Click the grab icon in the upper right corner. There's a little button. It says grab. Do you see it? Take a quick look. There you go. OK, so I'm going to go ahead and save this one. So let me save it. And then that's all that I'm going to do in SketchUp. So again, I'm minimizing the SketchUp content. And I'm back to Rhino. So I have a brand new Rhino file that's been opened. My units are in inches. This is important. You have to make sure your Rhino units are in inches because SketchUp units are in inches. And they'll come through that way correctly. So at that point, I need to go to File and then Import. I'm not inserting. Previously, we've done inserts of our blocks. I'm actually importing. So I'm going to choose Import. And I need to go find that SketchUp file. If you don't see it, make sure that you have all compatible file types showing so that you will see it. There's my Mount Diablo terrain. I'll go ahead and click on Open. The SketchUp options, it's going to come in as a mesh. The rest of these options are just fine. I'll go ahead and say OK. So here it is. I chose two new versions. So let's try a 2013. I told you we might run into that. So let me do a Save As. And let's go 2013 SketchUp. And I'll go back to Rhino and try that process again. File, Import. And I'll say OK. And there we go. It comes in. Yeah.
Sorry, did you save the SketchUp file that imported it?
I saved the SketchUp file as a 2013 SketchUp file. I'm not sure. It's a good question. Let's see what happens. If I did a Save As, DWGs generally don't preserve too much 3D information. Do I have to export it from SketchUp?
Just export.
Export 3D model. It would read a 3D Studio. Rhino can read a 3D Studio file. I don't know about a DWG. Did it open it? OK, so it should be fine. I don't think it's going to make a difference long term. The fundamental difference between SketchUp and or 3D Studio Max and Rhino is all of those software packages work with what's called a triangulated mesh, which is what we're seeing here. It's a bunch of little facets that make up our overall surface. In Rhino, we can generate a perfectly smooth surface, which is ultimately our goal. And that's what we're going to be working with today. So if you got what looks like this by importing the DWG, that's fine. Do a save as 2013. OK, then go to Rhino.
And then my dude came in.
And then import.
Yes, I did that. I imported it, but I got him.
OK, that's fine.
Is he okay?
You'll delete him.
Delete him.
Yeah. OK, so now I've brought that in. The file that comes in comes with two different pieces. One is a flat rectangle. This would represent the flat version of your site in SketchUp. The other is the terrain file. So I've got those two different pieces that represent the file that I brought in. I don't care anything about the flat piece. We can get rid of that. I'll select it and press the delete key, which leaves me with this piece of terrain. I want to take a moment before I move on, though, and take a look at my layers. So we see that there's a variety of pieces that came in with Google Earth. I'd like to clarify things just a bit. So I believe that the terrain is on layer 0. And I'm just going to call layer 0 SketchUp. For clarity purposes, I'm going to get rid of the Google Earth terrain layer and the Google Earth snapshot layer, which leaves me with just the SketchUp layer. OK? So I have the SketchUp layer. I'm currently working on the default layer. And now the next piece of this is that I'm going to need to convert this from this triangulated mesh. And you can kind of see as I zoom in, see how that ridge is a little bit spiky? There's straight lines and spikes. I don't want that. I want it to be nice and smooth. And so when I convert this, that's my ultimate goal. So what I'll do to do that is I'm going to use something called the contour command. And what contours do, if you imagine looking at like a topographic map, let's say you're going hiking and you look at a topographic map, it shows a bunch of contours, which are essentially parallel lines going vertically that represent each change in elevation as you go up. We're going to use the same strategy here, but we're going to do it in the x and y direction, not in the z direction. So not as if it were representing elevation change, but instead just contours of the surface. So I'm going to select, before I do that, I'm going to create a layer right here under layer 2, and I'm going to call this contour x for clarity. If I were doing this myself, I probably wouldn't create all these layers, but I've found over time when I'm teaching it to you guys, it's easier to create these layers so that you can see what I'm doing on each layer. So I'm going to call that contour x. I'm going to make the contour x layer active. So I double click to move the check mark down for contour x. And I'm going to do contours that are going in this direction. So I'll go ahead and go up to curve, curve from object, contour. I could also just type contour into the command line. And here, let me go back one step. With nothing selected, it'll ask me to select the object. So curve, curve from objects, contour. It's going to say select objects for contours. It would be that object. I'll go ahead and press enter. It says contour plane base point. I just want to pick one of these corners. It's not snapping to that corner, so I need to turn on probably my vertex snap, and then it'll snap to that corner. There it is in that corner. Next thing it asks me is direction perpendicular to the contour planes. So I want to draw a line that goes off in one direction or the other. The truth is I named this contour x. It doesn't matter whether contours x are all in the x direction or y are in the y direction. It's just a way of identifying that they're contours in one direction. I probably should call it contour 1 instead so that it doesn't confuse you. So I'm going to go ahead and draw a line. And I want this line to be going off infinitely in this case, it'll be in the y direction because my contours will be in the x direction. And to do that, I can turn on ortho to make sure that I'm snapping in my y-axis direction. I want to make sure that I'm not snapping to any of the other points on my object. It just needs to go off in space along that y-axis. I'll go ahead and click on it. And then it says distance between the contours. And this is going to vary based on the size of the terrain chunk that you had. I'm going to say maybe 100 feet. So I'll type 100 followed by the apostrophe for 100 feet. Don't type just 100 because then it'll be 100 inches, which is a lot smaller, and you'll get a lot of lines. With 100 feet selected, I'll hit enter, and we'll see that it'll divide up that terrain into a series of parallel lines that basically follow along this surface. Does that make sense so far? Okay, so now I have those. I want to make sure that I deselect everything else, and this is a big challenge because a lot of times people don't deselect before they repeat the process. I'm now going to do the contour Y, or contour 2. I'm going to start calling it contour 1 and contour 2 for clarity. So let me make contour 2 active. There it is. I'm going to do contour again. So same command. It'll be under curve, curve from objects, contour. Select objects for contour. It's going to be just the surface. Don't select the lines. I'll go back and show you what happens if you select the lines. I'll go ahead and hit enter. Contour base point, there it is. Direction perpendicular to the contour lines. This time I want to go in the opposite direction. So I did this way last time. I want to go in this way this time. Distance between, it's saved my 100 feet already as default, but I could also type in 100 feet. And I'll hit enter, and I'll get lines going in the opposite direction. So if I had done it incorrectly and I had selected and tried to contour where I had all of, let's see here. Let's say that I had my line selected here and I went to do a contour of this. So same thing, contour. I started right there and I said, okay, this is in the correct direction. There it is. And I went enter. I'd end up with all of these little points. You know something went wrong if you got points. So a contour of a surface gives you a line. A contour of a line gives you a point. We don't want all the points. So we just want lines. So if you get this, back up, delete, back up, etc. Control Z is your friend, exactly. Okay, so now I have lines in the X direction and lines in the Y direction. From here, I want to rebuild a surface from these. So I'm going to use that curve network that we used before to do this. And so when I do the curve network, we've got a couple problems. At this point, I can turn off the SketchUp layer and look just at my surface. If I look at this edge, see how I have a ragged edge along there? And I have a ragged edge along there? The curve network isn't going to work with that edge. Remember, it needs bounding curves all the way around. So I have two choices. If all of the terrain is critical, I can use my curve interpolate points, this one, and I could draw a curve that goes between all of these points. To me, that's a lot of work. So instead, I'm going to move my view into the top view, which, by the way, when you do this, your grid, it should look like a perfect grid. If you have it where the lines are kind of sloping or something, something went wrong during your contour. With this like that, I'm going to go ahead and select a few of these lines. I'm actually going to make it a little bit smaller to make my selections easier. Like that. And I'm going to trim off all of these ragged edges. So I'll type trim. And we'll get rid of these little ragged edges. Like that. It's pretty easy to do it from the right, the bottom, and the top. Doing it from the left side here is a little bit harder in terms of the selection, like that. Now what I end up with, if I went back into my perspective view, is a bound curve network of curves that I'm going to create the surface from. So once I get to this point, now's your opportunity to make sure you save your file. And I don't say that lightly, because the curve network is challenging. It's going to be slow on the computer. It's going to take a little while. You want to make sure you save it. In the old days, it used to crash the computers more than half the time when you try to do it. Now you have a pretty likely shot that it's going to work. You don't want your mesh to look any more dense than this. You could probably do it even less dense. I could probably do it at 50 feet by 50, or 200 feet by 200 feet and be fine. I'm going to go ahead and save this. So I'll go to File and then Save. It's going to go into today's folder. And I'm going to call this Terrain. OK, so now that it's saved, it's time to do that curve network. So it's under Curve. It's under Surface, Curve Network, or I'm going to type in Network Surface. Same thing we used 2 classes ago. Select Curves and Network. I'm going to go ahead and select them all and hit Enter. It's probably going to throw this warning at you that's saying I've selected more than 100 curves. It may cause Rhino to become unstable. Are you sure you want to continue with my 127 curves? Absolutely. Let's see if we can crash the computer, right? So it was able to determine I've got my 4 sides, A, B, C, and D. If it asks you to manually select curves, something's in all likelihood wrong. So you'll need to figure out what happened. It's probably in your contours not being parallel. That's most likely the issue. So from here, I do mention on there, if you're having a lot of trouble, you can change the edge curves to 0.1 instead of 0.01. I'm going to go with it at 0.01 and see what happens. I'll go ahead and say OK. And then this process can take a few minutes. So you have to be a little patient while this happens. There's not going to be a whole lot going on other than your little spinning wheel. Yeah? You're contouring the lines, not the surface. So select the surface before you do the contour. Select the SketchUp surface and then do the contour. OK, so it made my surface. It finished. And you'll notice at this point that the surface that it made is like a solid black object. Quick question? I left them as the defaults. So the surface that I get is this solid black kind of object. If I select that object, Rhino runs really slow, and it turns bright yellow. And if I were to try to orbit, it's like awful, right? That's because this surface is really dense, the resulting surface. As I zoom in, at some point, you'll start to see the U and the V lines that represent the surface. It's a really intense surface. There you can see it. It's way more intense than we need it to be. So I'm going to start by typing Rebuild. It's also available under the Edit menu. You can go to Rebuild. We did this to curves before, remember? I'm going to do it to the surface. I'll type Rebuild, and it's going to ask me to rebuild the surface. What are my point counts? I'm going to start at 200 by 200, and I'm going to show you what the differences here do. So I'll start at 200 by 200, and I'll say OK. And it will rebuild the surface. And suddenly I have Rhino back. It's not slow anymore. So we need to do that initial rebuild to get started. So when I do these rebuilds, I'm going to show you in contrast to the SketchUp surface. I'm going to create separate layers for each of these rebuilds so that I can toggle between them. In all likelihood, you're going to do one and call it a day. So I'm going to have more layers than you, essentially. So I'm going to start. This is my rebuild at 200. Let me take the resulting surface there, and I'm going to change the object onto that layer. I'm going to turn off my Contour 1 and Contour 2 layers so we have just the surface itself. So this is the Rhino surface. But if I look at it, it's done a fairly accurate job of representing the surface such that I can even kind of see the triangles left over. So it's not that smooth. I'm getting a little bit of the triangles. If I were to take this object, and I'm going to create a copy so that you can see the difference. And I'm going to move it onto another layer called Rebuild 100. Change object layer there. And then I'll rebuild this one at 100 by 100. and say OK, the resulting surface will get a little bit smoother. So if I turned off, oops, there, and I looked in that same spot, it's getting a little bit smoother. It's a little bit harder to see those triangular facets. If I compare these to the original SketchUp file, and I overlay those two, you can see where the data has smoothed out based on the various patches of gray. So I have in my options so far, there's my 200. We can kind of still see the grid pattern there. There's my 100. We're seeing less of the grid pattern. So if I did a rebuild at 50, for example, do another layer here. Rebuild at 50 by 50. Okay. It's getting a lot smoother. Those triangles are really starting to go away. So once again, there's my 200. We're seeing the squares, the triangular facets. We go to 100. It's going away. We could still see a little bit of it. When we go to 50, it's getting very smooth. We're losing almost all of those facets. If we look here, even at that ridge, it's pretty smooth across that ridge. So this is probably a pretty good happy medium for my particular surface. You have to judge at what level you want to do the rebuild. If I took this even further and I said, let's create a rebuild by 10, let me copy it in place and then change it here and rebuild it. There it is, and it's very smooth. So the problem here is if I were to take the 10, the rebuild by 10, and compare it to the original SketchUp surface, there's some pretty big areas of hill that have been smoothed out. So there was my original. There's a little ridge here. You can see where it's smooth through that ridge. So it's not nearly as accurate. So there's always a happy medium for your surface of what's the right level of rebuild. You can start at 200 and work your way down, 200, 150, etc. Once you start getting below 50, my guess is it's going to be a little too smooth. So for me, it's somewhere between 100 and 50. And so I'll take a look at those two one more time to see. Oops. 200 was too much. I think for me, 50 is about right. I think that's the one that I'll end up working with. Again, it's your choice as to which one you want to do. So from here, I've gotten to the point where I've gotten through step 3 on your exercise for today. And I'm going to move on to step 4, which is I'm going to create, this time, vertical contours. So like a topo map. So I'm going to create another layer. There it is. And I'll call this topography. Or topo, let's call it topo lines. I'll make that active. And I'm going to contour this surface again. But this time, instead of being in the X or the Y, I'm going to do it up and down in the Z. So I'll go back to contour. So let me go to surface. Excuse me, curve. Curve from objects, contour. Or type contour. I'll snap again to this lower corner. There it is. But I don't want to be in the X, and I don't want to be in the Y. I need to be up in that Z. And so it's not letting me get there. So I'm going to switch my view so that I can go into the Z in one of these side views. There it is, straight up and down. That's the way I want it.
What if it doesn't snap?
You don't want it to actually snap. So turn on the ortho and just make it go up in space so that you're not snapping to anything. You're just right along the axis, like that. And then distance between the contours, this time I'm going to do it at about 40 feet. And when I have that selected, we'll watch the perspective view as to what happens. I'll go ahead and hit enter. And you'll see that it'll work its way up the topography and slice it up for me, creating all those little vertical sections. Basically like a topo map. There it is. So I have those pieces. I could even turn off my rebuild by 50, and I'd end up with all of these pieces. What was your question? I did them at 40 feet. It's rather arbitrary. If I did them at 2 feet, I'd have too many. If I did it at 100 feet, I'd have too few. So 40 seemed like a good interval. The other thing is USGS maps tend to do 40 feet. So that's part of why I picked 40. Anyway, so there's my contours. I just sliced that up and gave myself these contours. Now, these are three-dimensional. So if I wanted to use them, say, to laser cut or something a little bit later on, we'd want to take this a step further. I need them to end up being flat on the ground. And ultimately, we will be laser cutting these, but there's a lot more to it than where we are right now. So I'm going to create another layer. So we'll do one more layer down here. And I'll call this AutoCAD. If I can type, there's AutoCAD. We'll make that one active. And on that layer, I'm going to create a surface that is larger than all of my topo lines. So we'll do a rectangular surface, corner to corner, bigger than all of my topo lines. I'll switch my view into the top view, and I'm going to do a project. So I'll go up to Curve, Curve from Objects, Project. Select Curves and Points to project. I want all of those topo curves. I'll hit Enter. Select Surfaces. It's going to be that flat surface. I'll hit Enter. And it will move all those topo lines onto a perfectly flat plane, which is ultimately what I want for AutoCAD when I go out. I can get rid of the big surface. I can get rid of my topo line layer, so I have just the flat topo lines. I can select these lines and then go to File, Export Selected. And I can change this to be AutoCAD. There it is. And we'll call this, I don't know, terrain. There it is. When I save, the default option here, 2004 polylines, is just fine. And I'll go ahead and say OK. That then wrote an AutoCAD file for all of those contours. Ultimately, we're going to be creating AutoCAD files so that we can go over to the laser cutter. So that's part of why I'm making you do it today. This file hasn't been scaled. It's not ready to cut. There's no red and blue lines. I mean, there's a lot still left to do. But this workflow is going to be rather continuous as you go through for the next couple days, which is part of why I'm making you do it today. If you get to the end of that, that's as far as I want you to get today. If you get to the end and you have extra time, I say on the handout that you could create a meditation pavilion and do a little rendering or whatever. I think you'd be better served if you worked on your table and chair. So hint, hint, that's what the extra time today is for, working on your table and chair. Okay? So like I said, I'm going to repeat all of this again multiple times. So we'll go through this whole thing again, and then I'll add to it next class. So it'll take me less time. I mean, today it took me 40 minutes to go through what I just talked about. It'll start getting less. I'll spend 20 minutes next class. I'll spend 10 minutes the next class to get through the same set of steps. But I'm still going to be repeating it. So you'll see it multiple times as you go forward. OK, so I'm going to turn you loose. The idea is when you post something today, ideally you'll post that AutoCAD file so I get an idea. You could also do a screen capture of your topo and post that. You'll have to do a featured image, so a screen capture might not be bad. If you want to do a screen capture of your table and chair that you were working on and post that, I'm OK with that too. But make sure that you actually post something for today under Exercise 211. Just because it's a little bit loose as to what you're supposed to be doing and you get time to work on your assignment doesn't mean not to post anything. So I don't want you to forget to post. Does that make sense? Yeah? OK. So you will all post for me. OK, good. I think that's it. So I'll let you go.